Let us prove by mathematical induction that 1 square plus 2 square plus 3 square plus dot 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 n square equal to n into n plus 1 into twice n plus 1 by 6. For that purpose, we define Pn to be a statement. Let Pn be the statement 1 square plus 2 square plus 3 square plus dot 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 plus n square equal to n into n plus 1 whole thing into 2n plus 1 by 6. Obviously, we should have n equal to 1, 2, 3 and so. Now, therefore, P1 is the statement. P1 is the statement P1 is the statement. If you take n equal to 1, then left hand side we have just 1 square. On the right hand side we have 1 into 1 plus 1 whole thing into 2 into 1 plus 1 divided by 6. And that is equal to 1 into 2 into 3 by 6, and that is equal to 1. Therefore, P1 is true. Therefore, P1 is true. So our induction step can begin, but induction is something like a cycle. Principle of mathematical induction is a kind of cycle kind of design. So we assume Pn is true for some n equal to k. So we have 1 square plus 2 square plus 3 square plus dot dot plus k square equal to k into k plus 1 into 2k plus 1 by 6. However, we are just assuming for some n equal to k, and we'll prove that if it is true for n equal to k, then it has to be true for Pn has to be true for n equal to k plus 1. So what will be the left hand side of pk plus 1? Then left hand side of pk plus 1 is 1 square plus 2 square plus 3 square plus dot 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 plus k square plus k plus 1 whole thing square. But by our assumption, 1 square plus 2 square plus dot 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 plus k square equal to k into k plus 1 whole thing into 2k plus 1 whole thing divided by 6, and k plus 1 whole thing square as it is. Wow, let's simplify this expression. We observe that we can take k plus 1 common. We take k plus 1 common. We are left out with k into 2k plus 1 by 6 plus k plus 1. This is equal to k plus 1. You can take the LCM 6. We have 2k square plus k plus 6k plus 6. That we can simplify it as 2k square plus 7k plus 6 by 6 as it is. We can factorize 2k square plus 7k plus 6 is 2k square plus 3k plus 4k plus 6 by 6. And so lastly it gets factorized as if we take k common, you are left out with 2k plus 3, and here also if you take 2 common, you are left out with 2k plus 3. Now this is equal to k plus 1 into k plus 1 plus 1 into 2 times k plus 1 plus 1, whole thing by 6, and that is nothing but right hand side of pk plus 1. Therefore pk plus 1 is true whenever pk is true. Whenever pk is true. Since we have assumed, since we have obtained P1 is to be true, by this last line we can say P2 is true. Again, if we take k equal to 2, we got P2 equal to 2, and then we'll have P3 equal to is true. Similarly, P3 is true, it will imply P4 is true. P4 is true, it implies P5 is true. So by principle of mathematical induction, Pn is true for every n.